Well, good evening.
Good evening, Gerald.
Good evening.
Good evening, everybody.
So, for those of you watching, we have a few extra guests tonight. We have a special program. This is our Observe the Moon night. So, you see Lisa Hoover over there. She's on my left. I don't know where she is on your screen, but she's going to be our hostess tonight. And we have several guests from NASA who are going to be joining us. So it'll be a really good program. So without further ado, Lisa, I'm going to let you take it away.
Caught it.
All right.
Excellent.
Thanks so much, Gerald. Once again, welcome everybody. Thanks for joining us. We are all here to celebrate the International Observe the Moon Night. Speaking of international, if you haven't already done so, tell us in the chat where you're watching us from. We'd love to hear from you. International Observe the Moon Night is a global event where you can learn about lunar science, exploration, and how to view the moon. Before we get started with our program, there is some breaking news that we just can't wait to share with you. We are finally reopening. The weekend of November 12th to 14th, we are opening with a 3-day center-wide celebration. You don't want to miss it. The opening celebration will include visiting scientists from the NASA Ames Research Center, as well as special performances by the Piedmont Children's Choir, drop-in workshops, robotics activities, several community partners, space-themed collaborative builds, engaging activities led by our teen Galaxy Explorers, and so much more. Timed ticketing is now available online. Don't delay. I can't wait to see you here. Back to our regularly scheduled program.
All right.
Our program tonight, the schedule will be Jonas Dino will kick it off with a live demonstration from the NASA Ames Center, followed by live virtual views of the moon led by our famous Chabot astronomers. Our guest speaker tonight will be Dr. Kimberly Inyo-Smith to talk to us about NASA's Viper mission, and then we'll end the night with more virtual viewing and your questions live. So once again, up first this evening, we have Jonas Dino. He is a NASA Ames educational specialist. He focuses on K-8 engagement with live space demonstrations. So if you haven't already done so, this is the part of the evening you want to go get the kids right now, bring a snack, everybody join around. Jonas also works with the NASA Office of STEM Engagement, supporting the Minority University Research and Education Project. So if there's no other announcements before we begin, Jonas, take it away.
Okay. Hello, ladies and gentlemen. Thank you for joining, and it's an honor to be able to present to you. Okay, so I'm going to go ahead and share my screen here. I'm going to start off with this thing right here, and then now go to live slideshow mode. There you go. Okay, I'm hoping.
Nope, not yet. Not yet.
Not yet?
Not yet.
Okay. Oh, there we go. Share. Okay, hold on a second. I'm trying to share. Screen sharing has failed to start. Please start again.
Oops. Don't know what that's all about.
Uh-oh. It worked earlier.
Yeah, you may have to rejoin the meeting.
Okay, let me quit out, and I am so sorry about this.
No worries. We excel in technical difficulties.
Yeah.
Virtual telescope program.
Okay, let me leave and get back in.
That's quite all right. Let's shout out some of our guests out here. We've got folks watching from Oakland, Berkeley, Hayward,
Oregon,
Alameda, San Pablo,
Sacramento,
Walnut Creek, Rancho Cordova, Galt, Pennsylvania, Texas,
All right.
Ohio,
Kalamazoo.
Tampa, Stockton, Castro Valley, San Leandro, Phoenix, Sacramento, San Rafael, all over the day, all over the place.
Yeah.
Paradise, Hawaii, Virginia. This is fantastic. Keep it going. Keep it
Yeah.
going.
Yeah.
San Jose, Novato, Mountain View, Seattle.
Okay. So
Here
do you-
comes Jonas again. Okay,
Yeah.
let me get
All right,
let me
he's
get
back.
you to turn on your video, and then you'll be able
oh,
to
there you
share
go.
your
Start my
screen.
video. There you go. Okay, here you go.
Let's give it a shot.
Okay. So let me share screen again. There you go. Share.
There we go.
Yay,
Got
okay.
it. Yeah.
Sorry about that, folks.
No
Okay,
worries.
so I am from NASA Ames Research Center in Silicon Valley, so just a few miles away from Chabot Space and Science Center. Okay, so I am Jonas Dino, a public engagement specialist, education specialist also, and I've been at NASA for 21 years. Okay, so let's start off with this is the logo for one of our missions, the Artemis mission. Okay, it's named after the Greek goddess Artemis, which was the goddess of hunt, wild animals, and the moon, and was the twin sister of Apollo. And so we named our new mission, which will send, and here are the goals, send astronauts, American astronauts back to the moon, including the first woman and the next man back to the moon. Okay, the other goal for this mission is to establish a sustainable presence on the moon to prepare for missions to Mars. Okay, one of those things that it's happening through the through the Artemis mission is the Viper mission. A really cool mission, and later on, Dr. Eniko Smith will talk about this. Okay, so my demonstration is about vacuum, vacuum of space, and so let's go see. I'm going to go ahead and so what I'm going to do is, what do you need if you go to space? You need to take a piece of the Earth with you: air, water, food, and shelter. Through this mission, through the Artemis program, we're going to harvest water from the moon, turn it into air, fuel, use it for water, grow food possibly, and build a shelter. Okay, how do you do that? You bring a piece of the Earth in a spacesuit, in a spaceship, a space station, or what we want to build on the moon, a moon base. Okay, so on the moon, it's almost a vacuum, or pretty much a vacuum. And so what would happen to you if you actually were exposed to the vacuum of space or the moon? Okay, what have you seen in movies and TV? You know, you see things where they're a little dramatic. So what they want is basically to show somebody blowing up, somebody freezing, and so on. And so the little bit more dramatic, they take a little artistic leeway on that, and it's not necessarily true. Okay, so if you were exposed to the vacuum of space or the moon, could you survive? The answer to that one is actually yes. Not for very long, less than a minute, but you could survive if you were transferring from one airlock to other that were really close to each other. Okay, think about these other questions here. Would you explode? Would your blood boil? Would you freeze immediately? Or if you did meet an alien, a scary one from the movies, could we hear you scream in a vacuum? Okay, so what I'm going to do here is I'm going to show you a vacuum demonstration using marshmallows, air pillows. These are packing materials that a lot of you have gotten because of the pandemic, and we've had a lot of things delivered home. Balloons, an alarm clock, and room temperature water. Okay, So now I am going to actually stop the presentation. And I am going to switch cameras to my other camera. Okay, so here is my vacuum chamber. They have a bell and a platform and so on. Okay, so first thing, let's start off with the marshmallows. Okay, so I have 2 marshmallows here. Okay, Jordan and Chris. Okay, and those are gender neutral names. You can have people named Jordan and Chris from either. Okay, so I'm gonna expose these to vacuum, and what do you think is gonna happen to the marshmallows? Okay, marshmallows are sugar, lots of air, and fun, delicious stuff. Okay, and so now I'm gonna put it in the chamber. I'm gonna turn on the vacuum. Watch what happens to the marshmallows. Okay, you see the marshmallows are starting to expand because there is air inside them. Okay, they're getting big. Oh! And, okay, I'm gonna go ahead and stop. Okay, so keep an eye on the marshmallows. Okay, so now I've reintroduced atmospheric pressure. So what happened was basically the marshmallows expanded because there's air inside them, and in a vacuum, air expands. Okay? One thing also that you notice, one marshmallow got bigger than the other. Number 2 got bigger than number 1. It's because number 2 is actually a store brand, and this one is a brand name marshmallow. So basically that means that they whip a little more air into the store brands than the brand name one. Okay, so now
and we have proved it here.
And we have proved it. Okay, so if you are exposed to the vacuum of space, what would happen? Would you hold your breath? Okay, because you know air expands. Okay, so here are the packing pillows. Okay, so if you held your breath, it's like a closed system, and so your lungs would be closed. Okay, so if you expose it to a vacuum, what do you think is going to happen? Okay, here we go. Woo! There you go.
Boom.
These ones were actually tougher than
Oh my God.
previous ones.
Yeah.
So, and
So,
That one was really
Oh.
resisting.
Holy moly.
those ones were stronger than the ones we did for practice.
It was.
Okay.
So basically, you do not want to hold your breath, because in a vacuum, it's not like this one, which is gradual. It would be almost instantaneously if you're exposed to the vacuum of space, and so your lungs would expand so quickly. So you would have to let out all the air in your lungs, and then you can survive as long as you have oxygen in your blood, which is not very long. So you want to get back into a pressurized chamber as quickly as possible. Okay. And,
It sounds to me, Jonas, like you'd have to be pondering entering
Yes.
vacuum before you actually entered vacuum. So
And-
that's the most terrifying thought that's come across here.
One of the things actually they realize this is what happens is because they have actually had some accidents where people have been exposed to a vacuum chamber on Earth, and the person started feeling certain weird things happening to their body, and but they were able to survive because they were able to get them back into a pressurized environment. Okay, so we have 2 balloons here. Okay, so now I want you to think about, what do you think is going to happen to the balloons? Okay, Here we go. I'm going to put it back in a vacuum. Okay, and as you can see, one is actually getting bigger and the other one is not. Okay.
Store brand air again or something?
Store brand. Okay, I'm gonna go ahead and let the air back in. Whew, okay, so the reason why this one expanded, you probably guess it, is because this one's full of air. Okay, this one is actually full of water. So that sort of answers the question: would you blow up if you were exposed to the vacuum of space? You would not, because you are mostly water, and the rubber of the balloon, you have skin that will hold you together, and therefore you will not explode. Unlike some of those movies and TV shows that try to make everything so dramatic. Okay, so I want to get some coffee, and so I have a mug here, and this is room temperature water. Okay. It's not hot, okay? So, or cold. So I'm gonna put it in. What do you think's gonna happen to the water inside the vacuum chamber? Okay, so I'm gonna turn on the vacuum here. Keep a close eye on the water.
Watch pot never boils.
I'm watching.
And there is the gauge there. It's getting close to a vacuum. Okay, so what do you start see? What are you starting to see there?
A few little bubbles down the bottom there.
Oh yeah, I
Right,
see
you're
them
starting to
coming
see
up from the
little
bottom.
bubbles.
Yep.
Okay, some of that is dissolved gases getting pulled out of the liquid, but here we go. We're getting close to a vacuum, and what's
We're
happening
boiling.
now?
It is boiling,
That's
yeah.
definitely not outgassing of gases and dissolved gases inside the water. Okay, so it's boiling. Okay, so I'm gonna go ahead and let the air back in. So, do you think I can make coffee with this thing? Let me see. Ah, no, just kidding. This is still cold. It's not. It's actually boiling, or it's boiling, but at room temperature, because you are taking the pressure that's keeping the molecules of water in a liquid state. And if you actually let this go on for a little bit longer, for a long time in a pure vacuum, it will actually freeze, because it is an exothermic reaction, which means that's a kind of reaction that gives off heat. Okay?
Oh.
Okay.
So
So the last demonstration I have is, if you are in the vacuum of space and you run into a scary space alien and you scream, would they hear you? Or like in Star Wars, you hear TIE fighters zooming by and their blasters, or when they blow up the Death Star. Hopefully that's not a spoiler for anyone. Do you hear the explosion of the Death Star? Okay, so what I have here is an alarm clock. Okay, it's an analog clock here, and I'm going to go ahead and turn on the alarm. So you can hear that, right?
Yep.
Oh, hold on a second.
Yep.
I accidentally turned it off here. There you go. Okay, I'm going to put it in the vacuum chamber. Okay, so you can still hear it because the vacuum chamber is still filled with air, and but it's a little softer because of the glass is blocking it. But I'm gonna go ahead and put it in a vacuum, and let's see what happens. Okay, we're getting close to the vacuum. Getting very close. Okay, that's probably enough. That's close enough to a vacuum there. Okay, so can you hear that? Some of you might still be able to hear because there is a little bit of air still left in there. It's not a pure vacuum. But as I let the air back in, you can hear it louder and louder. Okay, that is because the more molecules that are in there, the easier that sound is transmitted. The denser the material, the better the sound is transmitted. That's why water or sound in water travels so much farther than sound in air, because the water is much more dense than the the air. Okay, so gonna go ahead and turn that off. Okay, I'm gonna go ahead and share my screen again, and we'll go back to our questions here. Okay, I hope everyone sees the. Okay, so if you are exposed to the vacuum of space or the moon, could you survive? Yes, you can, for about a minute, a little less than that. Depends on, again, how much oxygen is in your blood before you pass out. Would you explode? No, the balloon demonstration showed that. You're mostly made out of water and your skin would hold you together. Would your blood boil? No, it wouldn't, because it's inside your body, but the liquid, your saliva in your mouth would start to boil. Okay? Would you freeze immediately? No, you won't. Space is a vacuum, and that's why we have vacuum in between the walls of your flasks, your drinking thermoses and stuff like that, because it prevents water, it prevents temperature changes. And so basically you would not freeze immediately in space.
Well, vacuum is a good insulator, right?
Yes, it's a good insulator. And then again, if you screamed, met an alien and you screamed, would we hear you? No, we would not. So that ends my demonstration for tonight. I want to give you a few resources here. For teachers there, if you want, or people that do groups, if you would like a NASA speaker, we have a NASA Speakers Bureau. I'll put these. I'll send these to the Chabot folks so that they can put it in the chat. Okay, and the things about the space, or do we need pressure? How people survive is from a why do we need a pressure suits from a NASA aeronautics guide. And then for everyone who wants to look at what NASA's doing education-wise, go to our NASA Office of STEM Engagement website, and it has resources from kindergarten to graduate students. So that ends my presentation. Thank you very much. It was an honor to be part of this presentation. Thank you.
Thanks, Jonas.
Outstanding.
Jonas, I hate to say this, but I've got a whole shelf full of science fiction movies that you just ruined.
Well, but look on the bright side, though. At least we know we can make iced coffee in space.
Yeah, there you go.
And if there's any questions, you could always send it to me, and I will answer them.
Yeah. Colleen made a comment. She said that you that means that there's no spitting in space because it would all boil away, right?
It would boil and freeze really. It freeze because it's boiling away, and again, it's an exothermic reaction.
Yeah.
So yes. Well, again, thank you very much, and I look forward to the rest of the program.
Thanks, Jonas. That was amazing. If you're just joining us, if you missed any part of the program, you can rejoin this. You can watch it later. It will be available forever on Facebook and YouTube. And if you'd like to commemorate tonight's program, you can actually get a personalized participation certificate from NASA's International Observe the Moon Night with your name on it. So we will post the link in the chat on both social media platforms if you'd like that souvenir. Well, are you guys ready to observe the moon. That's what tonight is
it
for.
is International Observe the Moon Night, after all, so maybe we should do that.
Let's do that. Take it away, Phil.
Yeah, we'll spend about 5 minutes doing that. We'll get a first look at the moon. The moon is up tonight. We have clear skies, and you can see the view through the telescope here. I'm going to adjust it a little bit. We are in live view, right, Rick?
Yeah.
Yes, we are. We're
Okay,
live.
there we go. Yeah. All right. So we're going to start at the northern part of the moon, and then we will slowly over the course of the evening work our way south, eventually ending up at the southern part of the moon. The region that you see right now, that big smooth area that you see up at the top, that's called Mare Imbrium, or the Sea of Imbrium. It is a huge impact basin. Mare Imbrium is about 3.8 billion years old. It's when a very large asteroid hit the moon and produced quite a large impact crater. In fact, that impact was so forceful that the shock waves from that impact traveled all the way around to the other side of the moon and jumbled up the surface of the moon on the backside. When all those shock waves came together on the backside of the moon, it kind of created a jumbled territory exactly on the opposite side of the moon from where the Imbrium crater is. Rick, I'm going to ask you to kind of point out a couple of things here as soon as this thing moves.
Let's see if I can find a pointer.
Yeah, I see your pointer.
You see it? Okay.
Yeah, the pointer's fine.
Yeah, it's kind of red. So right up at the top of the image there, you see kind of a half circle region.
All right.
On the top of the Imbrium Basin.
Top of the Imbrium Basin.
Yeah, right there.
Like this right here?
Right there.
Okay.
Yeah, that region is called Sinus Iridum. Sinus Iridum is another smaller impact crater that happened roughly the same time as the Imbrium impact, but after the Imbrium impact. So when this impact occurred, it produced a huge crater, and this happened again 3.8 billion years ago. At that time, the moon still had a molten interior. So this impact cracked the crust all the way down to the molten interior. And then over the course of hundreds of thousands of years, lava oozed up through the cracks and slowly filled the Imbrium Basin. So that large dark area that you see there that seems very smooth, that's the lava that had filled the impact crater that produced the Imbrium Basin. It spilled over into Sinus Iridum. And then if you look right at the right edge of the frame, you see a round crater with a very smooth floor. That's called Plato. And it is also a somewhat more recent impact crater, that one right there.
Yeah.
But again, because all this lava was oozing up, it filled that crater as well. So,
Hey, Gerald?
Yeah.
Let's give folks kind of a perspective of where on the moon this is, real quickly.
Okay.
And if you don't mind, I'm just going to very briefly
share
through the finder scope. And the Imbrium Basin is this area right here. All right. So everything you were looking at, this was this little frame here, is what you were seeing through Rick's camera. So it's in the upper left quadrant here of the full image of the moon.
Yeah. Now we got about 1 minute left here.
So Rick, why don't you take it back?
Yeah.
Okay.
And we're going to continue the tour, folks, but we're going to go back and forth between the tour and the talks here. So you've got the Imbrium Basin, you've got Plato. If you look just above Plato, you see another smooth area that's called Mare Frigoris. It's another sea. The reason we call these seas is that when you look at the moon with your naked eye, you see dark areas and light areas. And these mares are the dark areas. It's the dark lava that has filled these basins. And so when you see it with your naked eye from Earth, you see those dark features, the features that we call the man in the moon or the rabbit in the moon or the witch in the moon, whichever particular culture you subscribe to. So that elongated smooth area just above Plato, that's called Mare Frigoris. Then that half circle at the edge of Mare Imbrium is called Sinus Iridum. And then the circular crater with a very smooth floor, that's called Plato. And I think now we are going to go back to Lisa, right?
Yep.
All right.
And I'm back. Thanks for staying with us. Get my computer up to speed here. So up next, wow, the moon is looking fantastic tonight. Our guest speaker tonight is Dr. Kimberly Enicle-Smith. She is a NASA scientist who loves exploration, learning, embracing inspiration, and sharing authentic conversations, especially over a cup of tea, about the wonders that surround and motivate us. She was born in Teaneck, New Jersey. She grew up in New Milford and Westwood, New Jersey, and studied physics at the Johns Hopkins University in Baltimore, Maryland. Funded as a British Marshall Scholar and American Association of University Women American Fellow and Amelia Earhart Fellow, she obtained a PhD in astrophysics from Cambridge University in Cambridge, England. She has designed and built infrared, airborne, and space telescope cameras and spectrometers, tested detectors in laboratories, and particle accelerators, designed low-cost suborbital instruments, and built lunar payloads. She has authored over 120 peer-reviewed papers and delivered over 50 invited technical talks and over 70 public presentations about astronomy, space exploration, and STEM. Asteroid 154587 Enicle is named for her. She's famous.
Right.
Following her talk, we'll learn more about the Viper mission, and we'll take your questions live. So stay with us. And without further ado, Dr. Enicle-Smith, welcome.
Well, thank you. And doing a comm check, how you read me?
Yeah, it sounds good.
Loud and
Great.
clear.
I'll get you spotlighted here too.
Okay. Well, it is an honor to join you all for International Observe the Moon Night. And I'm a lowly scientist at NASA Ames Research Center in Silicon Valley. I have a current role right now as a Viper Deputy Project Scientist to share with you a short presentation this evening about our lunar rover, roving where no rover has gone before. So to begin to kind of tell you the story in a nutshell, because I like telling stories, NASA is sending a mobile robot to the surface of the south pole of the moon, a place we have never visited before. Her name is Viper, which stands for the Volatiles Investigating Polar Exploration Rover. This explorer will give us the first close-up views of the location and concentration of water ice, whose presence on the moon was only discovered in the last few decades, and we still have so many questions about it. Data from Viper will generate our first water resource maps. The moon's south pole is also where humans will land under the Artemis program. Water is extremely critical for deep space exploration. It's a resource of direct value for humans as it can be turned into oxygen to breathe and serve as a fuel supply. Viper will bring us significant steps closer to NASA's ultimate goal of a long-term human presence on the moon and make it possible to explore Mars and beyond, expanding our knowledge and technology for the benefit of humanity and Earth. But first, today, happy International Observe the Moon Night. You just saw glimpses of our moon up in the night sky. It's a time we take a moment to reflect on our nearest neighbor in the cosmos. Soak in a new look of the moon and learn about it together. Tonight, our faithful celestial companion is 88.1% illuminated, a phase called waxing gibbous. It has risen in the east around mid-afternoon. It's high in the eastern sky at sunset and visible through most of the night sky. And it will set a few hours before sunrise. The image you see here is not from the wonderful telescopes at Chabot. It's actually from Stellarium, which is a free open source, awesome planetary program for your home computer. I set it for Earth coordinates, Oakland, California, 9 p.m. local time. We can see the mare, plural maria. Those are the dark plains of lower elevation. It's language from 17th century Western astronomers who got it wrong and thought they were seas, but in reality, they're huge basins containing cooled off lava flows. There are about 20 major areas. If you have exceptional vision, or with the aid of binoculars, or the viewing that you'll have at Chabot this evening, you can make out some of the craters or impact sites, or perhaps the montes or mountainous regions, highly reflective in the sunlight. We can reflect on the fact that we have visited this neighbor. Shown here, Russia, formerly the Soviet Union, had 8 successful soft robotic landings. Soft means it was successful enough to continue the mission after landing. They had 2 with rovers and 3 with successful sample returns. The US had 5 successful soft landings, robotic, and the 6 successful human landings. You perhaps know them as the Apollo missions from 1969 to 1972. And then more recently, China has had 3 successful soft landings, 2 with rovers, 1 of them on the far side, and a recent sample return mission, which is already causing a buzz in the community, revealing rocks much younger than we expected, meaning something kept the surface of the moon, or at least in some areas of the moon, a bit more molten longer in our moon's history. And when the moon becomes full next Wednesday, October 20th, those far west landing sites come into view. So we reflect upon those first surface expeditions of the 1960s and 1970s. The moon was a very different place than how we understand it today. Yes, we studied it from Earth. We studied it from lunar orbit. We studied it from the surface with our robots and with humans. And we had more landers and even rovers. We studied it in situ and even returned samples to Earth for scrutiny. The general thinking then was the surface is relatively constant. The moon has a thin exosphere. We wouldn't call it an atmosphere, but it has measurable amounts of argon, sodium, and potassium. And the moon was bone dry, 250 times drier than the Sahara Desert. However, that view has changed dramatically when a new fleet of missions, international missions, orbited the moon in the late 1990s and early 2000s. Shown here is just a sample. From left, Lunar Prospector, then LRO, the Lunar Reconnaissance Orbiter, still in orbit the moon 12 years and counting. Chandrayaan 1 and 2, Kaguya, and Chang'e. All these missions flew different types of scientific instruments, and equally important, they looked at different areas of the moon. Among the new learning and unexpected discoveries, there was a discovery of enhanced hydrogen at both lunar poles. This led to the question, could that hydrogen be in the form of water ice, since water is H2O at the poles? Is the moon not as bone dry as we once thought? So let's put the lunar poles into perspective. Shown here is the moon, and the numbers represent those Apollo landings. The poles are a long way from those equatorial Apollo sites. This video is zooming into the lunar South Pole. only a perspective you can get from orbit. The illumination conditions are quite different at both poles compared to that at the equator. And this is because the sun is at very, the sun is at only gets a few degrees above the lunar horizon. This creates a geometry where the shadows are cast very long. In fact, the shadows at the poles could be up to hundreds of miles long. It is a very dramatic and off-worldly scene illumination-wise. So we're zooming in, and near the poles, the sun against the topography is casting these long shadows. And in fact, there are certain areas that never see sunlight. And some areas may not have seen sunlight for the geological history of the moon. So imagine 4.5 billion years of darkness. We call those permanently shadowed regions, and they're found at both lunar poles. So let's look at the Shackleton crater near the moon's south pole. So similar to how we experience a temperature drop if we're in the shaded from the sun, these areas are always in shadow, are also very, very cold. Showing you the data. Here's the surface temperature taken actually during lunar summer. And blue is 100 Kelvin or minus 280 Fahrenheit. Your eyes might spot some areas colored purple. They have surface temperatures near 25 Kelvin or minus 415 Fahrenheit. That's colder than the surface of Pluto. And then zooming out a bit more, the lunar south pole has a lot of cold. Now, these cold areas also appear to be associated with high neutron suppression. That's the actual measurement. And that's indicative of lots of hydrogen. Remember that hydrogen discovery I mentioned earlier? It's shown here in dark blue in the image. Additionally, these areas are also associated where water ice on the surface could be present, represented by cyan dots. Each dot is a pixel on one of the orbiters, about 1,000 feet by 1,000 feet. So today, from many missions, we have confirmed that there's patchy or buried distributions of water and potentially different reservoirs. That bone dry moon from the 1970s, well, none of the Apollo samples came from the polar regions. There is water on the moon. In fact, we could have between 100 million to 1 billion metric tons. And scientifically, having water on the moon complicates a lot of our understanding of its formation. Water typically does not stick around. We call molecules that don't like to stick around volatiles. They prefer to go to their gaseous state and escape. Now, when you combine lots of data, different data sets, and make some assumptions about accessibility or predictions, you can start to see where multiple data sets infer and predict and point to ice. This is where the research is today. The ice favorability maps. Here, light blue indicates where water ice might be. Knowing where the water might be is only half the story. Our knowledge is quite limited. It's based on data taken from orbit. Even our best constrained data points are 1,000 feet by 1,000 feet, or 19 acres in area size, 14 football fields. We really need to get the ground truth, literally. And this is Viper. Viper is that mission. It's a golf cart size, solar battery powered 4-wheeled rover designed to withstand those frigid lunar polar temperatures, plus warming in the sunlight for its solar panel charging. And it's equipped with water hunting and water measuring instruments. Viper is the first resource mapping mission on another celestial body. In late 2023, Viper, the Volatiles Investigating Polar Exploration rover, will land at the lunar South Pole on a high ridge near the western edge of Nobili crater. Although the exact details of the mission area shown by that blue box are still being worked by the mission team, This location provides access to a range of ice terrain types. The rover will typically move at 10 centimeters per second, about twice as fast as the Mars rovers. This speed is needed for the instruments that are collecting data as the rover moves to map out the surface water concentrations and also observe the environment conditions. The mission will generate maps at an unprecedented scale, the meter scale, the rover scale, the human scale, maps of where and how much water. With this initial surveying, we can test and refine our current theories of how water got to the moon and why it's still there, and also make knowledge predictions of where and how much water is on the moon in similar environments and scales. At selected locations, the rover will stop. A drill is deployed to assess the water beneath the surface. Current theory predicts water ice to be buried, including areas not in permanent shadow. The drill aboard Viper brings up the lunar soil, the regolith, into a pile observed by spectrometers designed to determine the amount and type of volatiles buried. A camera underneath will also take images. The shape of the drilling pile plus inspection of the rover wheel ruts made in the lunar soil can tell us about the nature of the lunar soil at these high latitudes. A rover has gone to a place on the moon that no rover has gone before. All this information will help piece together a story of where and how much water ice is on the moon. Occasionally, the rover needs to go into shadow, especially sampling those permanently shadowed regions where water ice could actually be at the surface. Remember those blue, purple cold areas in shadow for billions of years? Well, when the rover goes into shadow, it needs headlights to see where it's going and to avoid obstacles like craters and rocks. The rover is designed to go up and down slopes of 15 degrees. Over a period of 100 days, the Viper rover will drive through a range of ice terrain types, places where those ice favorability indices are both high and low. The area that Viper will study in the Nobili region covers an approximate surface area of 36 square miles, about 10 to 15 miles of which Viper is expected to traverse in those 100 days. This particular reference traverse shown in pink is not the final traverse, but something for the science team right now to optimize. It's attractive because it brings the rover close to two large permanently shadowed regions shown in light blue. These are areas of high scientific interest and perhaps of water ice at the surface. Viper joins a bunch of rovers on other worlds, all shapes and sizes, each designed for their unique task. The past decade of observations have built a fascinating and complicated story about lunar water. Shown here are selections from scientific papers. From frost to buried ice blocks, there appears to be water everywhere, but its nature and its distribution is highly uncertain. The next steps require a surface asset, including surface mobility. This is a rover. So Viper will give us this level detail of where the water is and how much is available for us to use. And we can put together a better story of water on the moon. Viper's water resource maps and science observations will allow scientists to better understand the distribution of water on the moon and help inform Artemis crewed missions, visualization shown here, to establish a long-term presence on the lunar surface. Water is critical for deep space exploration, a resource of direct value for humans because it can turn into oxygen to breathe, serve as a fuel supply, even be used for water to drink. Viper will also inform future landing sites under the Artemis program by helping determine locations where water and other resources could be harvested to sustain humans over extended days. I end with The Viper mission may be short and sweet, 100 days, but Viper will prefer that first, next, and important step to understand story of water on the moon, our next great leap. For the latest mission updates, please visit our website, shown here on the slide, and thanks. Introduction to Viper.
Wow, that was fascinating. I can't wait for this mission. We have a few moments left. If you have questions for Dr. Inigo Smith, get them in the chat right now. What most excites you about this mission?
Well, actually, it's I've never worked on a rover mission before, but what's really neat is we're going to be driving the rover from the Earth. We're going to be what's called waypoint driving. We're going to tell the rover to go ahead 4 to 8 meters, and it will move from point to point. What's also very exciting about the hands-on driving the rover is the fact that our science team is going to make decisions in near real time based on what the rover instruments are showing us, because we are really going into territory we've never explored at this scale. So the scientists will be constantly checking our predictions and then making recommendations. So what's kind of exciting is just that it is a hands-on mission, 100 days, and we are going to be soaking in all the new knowledge and being reactive to it.
Wow.
Kimberly, I have a question for you. I see solar panels on the side of the Viper. Is that the primary source for electrical energy?
Yes, it is. One of our instruments on board is to look for neutrons. This hydrogen signature is related to neutrons. We couldn't carry a RTG or a radioisotope thermal generator, which is the power source for the Mars. It would be awesome for us because we could be in the dark craters forever. However, that interferes with our primary water hunting instrument. So we have to be solar powered.
So how long can the Viper go without direct sunlight?
We can hold on our batteries up to about 70 hours.
Oh, okay, that's nice. Okay.
And this is why we have an overly constrained mission. But the solar powers, we actually will be going in and out of the shadows, and we have to park our rover in constant sunlight. So we're up on high ridges to get areas where we can get a lot of sun. When we have to sleep when the Earth goes below the horizon, because we only drive when we're in direct communication with Earth. So yeah, the solar panels were desired to not interfere with the science, but they caused us to have a very constrained mission design.
All right.
Wow, that's amazing.
So what kind of questions are we getting?
We got a couple in Facebook. Do you see those, Lisa?
I sure do. We have a question here. If we and other moon visitors were to use all the water, then what? I'm assuming it wouldn't retrograde?
Use all the water. Well, we would also be very smart, I hope, to recycle our water. In fact, recycling water aboard the International Space Station, which has been occupied by humans for over 20 years, they have figured out how to recycle their water and reuse it. We still bring water from Mother Earth up to the International Space Station. So when we're on the surface of the moon and harvesting the water, we would need to make sure that we're recycling it for our use.
But there
and
is
of course, some of it will be destructive if you're using it for fuel and going somewhere else. So.
But there is a lot of water. If your data is correct, there's a lot of water there.
Yeah, 100 million to 1 billion metric tons at both poles. Now, how accessible that water is a big unknown. A lot of that reservoir could be quite buried. And that would mean a different type of excavation engineering needed. So we're going to make those maps to figure out how much is at the surface, how much is easily accessible, how much is hard to get at.
So there was a question about whether any of that ice might produce ice geysers or plumes similar to what we see, for example, in Enceladus.
Oh, great question. Well, the thermal heat from interior of the moon is not enough to allow that to happen. But perhaps, but it is happening in other places of the solar system, just like the icy moons of Jupiter and Saturn, which when you're out looking at the moon, go look towards the west and go look at Jupiter and Saturn. They're up in the sky tonight too, which you'll see them with your naked eye, very bright planets.
Awesome. We have another question here for anyone in the group here. Have the moon orbiting satellites found water in the craters in the shadow? Do they or will Viper have ground penetrating radar to detect it?
We don't have a ground penetrating radar on this rover. Man, we need another rover with a ground penetrating radar. Yeah, that's a great instrument to help us sound out the deep reservoirs. So future engineers, come on, we need to send that up as well. So yeah, the instrument complement is enough to have us do the initial maps, but we're going to have a lot more questions. And if we're finding that the water reservoirs are deeper than our drill only goes down to 1 meter, then we're going to be wanting a ground penetrating radar on the next rover.
And would that be true for satellites as well?
What was the question about satellites?
Whether
Same
they're
question.
detecting water in the shadows.
Oh, satellites, you mean like orbiters around the
Yeah,
moon?
Right.
Looking down.
lunar
Oh,
orbiters,
that's
yes.
that's already has happened. In fact,
Yes.
there's a fleet of new missions that will also carry additional types of measurements to refine our knowledge of that. But yes, the indicators from several orbiting missions from the past have confirmed or highly make you want to the data overlap such that there is surface ice in those shadowed regions.
Right.
So then you have to think about how you're going to get to those shadow regions, because if they're in the basin of a crater, you either have to land directly into that crater or you have to get over the rim and go down into that crater. So there's a lot of accessibility challenges, even though they have the strongest signature for surface ice, which means it's easy to get at, but it might be hard to get there.
Another question from Christopher. He asks, will the moon water be safe to drink?
Very good question. 12 years ago, I worked on a mission called L-Cross, and we actually crashed into the moon deliberately in the Chabot crater at the South Pole. We excavated, and today it's the only in situ measurement of the basin of a permanently shadowed crater. And in that, we found lots of water, but we also found a lot of other things, a lot of contaminants. So safe to drink. It had a lot of mercury, and of course, it had argon and potassium and sodium, but it also had organics. So one of the things that we're really interested with our instrument is to look for contaminants. We're looking at hydrogen and sulfur and carbon dioxide and other molecules to give a first assessment. But yes, we're expecting they're called cold traps for a reason. There's almost like a garbage dump of the solar system where anything can go.
It's a super fun site, right?
Many of them. Yes.
But it could be quite useful. We just don't know what's there. So
We can test some new technologies for purifying water.
Exactly.
All right.
Well, that was fascinating. Thank you for sharing this update on the Viper mission. I think I learned a lot. I hope everybody watching did. And I think it's time for us to check on the moon again.
Yeah.
And happy International Observe the Moon Night. But observe the moon as much as you can. It's such a beautiful part of it's our nearest neighbor.
Right.
And, we're all looking at it tonight for one night, but we always look at it 2 weeks out of every month during the night.
Thank you, Kimberly.
Yeah, that was great. So, Rick, I think we need to share your screen again.
There we go.
All right.
We are
Okay.
live.
All right. Well, the moon has drifted a little bit, so let me just adjust the camera a little bit here. And we're actually outside of where I wanted to look.
I was going to say the moon has drifted a lot. Who's driving?
Yeah,
this?
yeah, I know.
Who's
we
driving
have
this
this on
thing?
Yeah, we had this thing all set up a little
Yeah.
while ago.
I was going to say, what happened?
All right, so a little while ago we were talking about the Imbrium Basin, and now I've overshot.
That's right. Yeah. Let's go this way. Follow the little
Yeah.
cursor. Yeah.
All right, let's see what
Okay.
happens here. Want to go a little farther? There we go. All right. Okay, so the smooth area that you see in the upper half of the image here, that's Mare Imbrium, the Imbrium Basin that we were talking about before. But I want you to look down, sort of bottom middle. You'll see a bright crater right there. That is the crater Copernicus. Copernicus is a relatively young crater. Remember we said that the Imbrium Basin is somewhere around 3.2 billion years old, possibly as much as 3.8 billion years old. The Copernicus crater is only about 800 million years old. So to us, that sounds like pretty old, but in terms of lunar geography, it's a relatively young crater. And it's a very interesting impact crater. It has a number of features. If you look around it, you can see all these bright streaks extending out away from it. Those are ejecta rays. So when this impact occurred, material was thrown up out of the crater, and because of the weak gravity on the moon, it was thrown quite a long distance away from the crater itself. So those streaks are ejecta from the crater.
I'd like to
Rick?
give people a sense of just how far those ejecta go.
Yeah,
if
you're
you don't
talking
mind.
several hundred miles.
Yeah, so
Oh.
if you bear with me here for a moment, Rick,
Well-
I'm going to take it away and then
Okay.
you take it back. But you can see in this image that the ejecta go all the way up to here.
Yeah, there's one that's going diagonally up to the right that goes
And
quite a
up to-
long way.
all the way up to here.
Yeah,
Yeah.
yeah, yeah.
Well,
So that,
well, to give you a lunar ruler of sorts, the diameter of the Copernicus crater is about 55 miles, just under 55 miles in diameter.
All right, Rick, go
all
ahead
right,
and take
all
it
right,
back.
all right.
So looking right here at Copernicus again, this is about 54, a little more than 54 miles in diameter. And you can use that as a ruler to judge how far the ejecta lines go.
Rick, for a couple of minutes here, can we just zoom in a little bit? Not a lot,
Sure.
just a little bit. I want to be able to see the terraces in the rim. This type of crater is called a complex crater, and those types of craters, a lot goes on in the inside of the crater. Yeah, we're really not
Not
getting
too much.
Nope, hold it right
All
there.
right.
Let me see if I can improve the focus at all. That didn't.
Yeah, let's go the other way.
What happened there?
Okay. Well, I think it just lost its lock there, but we can get it back. Let me go. All right, that should come up.
All right. So,
That's not bad.
yeah, that's not too bad. So what I want to call your attention to is if you look around the rim of the crater, you can see what looks like terraces. And what happens when this,
I think it's good.
Yeah,
It's a
just-
time.
your system
Just
has a
time.
mind of its own.
Yeah,
Yeah.
just use the plus signs, and
Okay.
those work better.
All right,
What's
a little
that?
bit, more. There you go. There you go. That's good. So you see these looks like terraces around the rim, and what happens is you get this big impact, and it throws material up. It kind of digs a hole, and a couple of things happens. First of all, it compresses the regolith and the crust underneath the crater, and it pushes everything out to the side, creating the rim. but the rim doesn't stay pushed out to the side. A lot of it slumps back down into the crater. At the same time, that compressed center of the crater, once the energy is dissipated, it sort of bounces back up a little bit. And so you end up with a peak in the center of these larger complicated craters that's called a rebound peak. And it's a combination of material slumping down from the side, from the walls, and this rebound of the center of the crater as the energy is dissipated. So now what you can't see here is you can see those ejecta rays, but if we could really zoom in and get some really good resolution, which I don't think we're going to be able to do tonight, we can actually see secondary craters. Some of the ejecta was actually pretty good sized rocks and boulders that produced their own little craters. And so surrounding Copernicus are all these secondary craters caused by big rocks and boulders that were ejected out of the main crater, and then they landed adjacent to it and produced additional craters. All right. So, Rick, if you can zoom out again.
Okay, we're out.
All right. And then just to the right of Copernicus, you see another crater. In fact, if you want to zoom in right there, that one, if you want to zoom in a little bit, not too much, just a little bit on that one. All right.
You want to go in deep?
Perfect. Right. Okay. Just like that. Okay. So that crater is called Eratosthenes. Now, remember I said Copernicus is about 800 million years old. Eratosthenes is a much older crater, and so you don't see ejecta rays around it. It doesn't have a bright rim. It's about 3.2 billion years old. It's a very old crater. Eratosthenes is named after a Greek philosopher named Eratosthenes, who somewhere around the year 240 BC, he attempted to measure the circumference of the Earth. Contrary to popular belief, even back then in 240 BC, they knew that the Earth was a sphere, and Eratosthenes attempted to measure the circumference of the sphere by a very ingenious technique. He was in Alexandria, which is right on the northern shore of Egypt. Farther south in Egypt, several hundred miles south, was a town called Syene. And in Syene, there was a well. And that well was situated such that 2 times each year, the sun was directly overhead of that well, so that the sunlight shone straight down the well, and there were no shadows in the well. So what Eratosthenes figured out is if the Earth is a sphere, by putting another stick straight up and down in Alexandria and measuring the shadow on that stick, the angle of that shadow from the top of the stick down to the tip of that shadow would be the fraction of the Earth's circumference represented by the distance between Syene, the well in Syene, and the stick in Alexandria. And so he used that technique. His methodology was sound. It was perfectly logical way of measuring their circumference. He came up with an answer which we think was pretty close, not exact, but it was pretty close. But his methodology was spot on. So that was Eratosthenes, and that crater right there that you see is named after Eratosthenes. Now, to the right of the crater, you see what looks like a mountain range. And there are actually several mountain ranges on the moon. And what's interesting is we often name mountain ranges on the moon after mountain ranges on the Earth. So that mountain range that you see right there, that's called the Apennines. Rick, if you can zoom out a little bit. Here we
That's
go. Yeah. Okay, that's as good as you're going to get.
Yeah.
So let me move this over here a little bit, and we'll look at a couple other mountain ranges. There is a series of mountain ranges that surround the Imbrium Basin, and we're going to head on up a little bit. All right, so you see a little bit of a gap in the mountain range there, and then there's another mountain range. So there's the gap, and then just north of that is another mountain range. That one's called the Caucasus, which again is named after a mountain range on Earth. And then if we go up here around Plato is another mountain range called the Alps. So you have the Alps, the Caucasus, and the Apennines on the moon, which are all named after mountain ranges on the Earth. Okay, so let's head south a little bit more. And there's a feature down here that I want to call your attention to. We'll go a little bit east. It's not going to show up very well. Right there. Actually go up a little bit, and there's a large crater. It's kind of faint. Right there.
One.
Okay, that one's called Ptolemaeus. And then directly below it is a crater. No, a little to the left. That crater right there is called Alphonsus. And then directly below that is Arzachel. I may have the two reverse. Actually, to the right a little bit, Rick.
This one.
Right, yeah. So these three craters, which are much easier to see when you use a telescope and look at the moon a couple of days earlier than what we're looking at now, they show up very nicely. And amateur astronomers like to call that the snowman. A lot of times, amateur astronomers use telescopes that flip the image of the moon. So when you look through the eyepiece of their telescope, you see the moon flipped over like it's upside down. And those three craters, the bottom one is small, the middle one's a little bit bigger than the top one. Ptolemaeus is the biggest one. It looks kind of like a snowman in your view. So we call that the snowman. So I don't want to use up too much time here because we want to leave some time for questions. So I want to continue on down to another crater down here near the bottom. And that's the crater Tycho. So you see Tycho right there. And if you again look, you'll see these long rays extending away from Tycho. And in fact, Rich, if we could go back to your wide view.
Yeah, it's really dramatic. Hold on. And here we go.
Tycho is a fairly young crater. It's only about 100 million years old. So that in lunar time, that's really young. And you can see those rays extending away from Tycho.
All the way out to here.
Over 1,000 miles. Yeah. Some of those rays extend over 1,000 miles.
All the way out to here.
Now, Tycho is another complex crater. It's got a rebound peak at the center. It's got terracing around it. And if you have ever seen the movie 2001: A Space Odyssey, Tycho is the location of the Tycho anomaly, the monolith that they found on the moon. So let's go back to Rick's image. And Kimberly, if you're still on, maybe you can help us out here. We'll try to get all the way down to the south. And maybe you can help us point out where your Viper is going to go. Are we live?
Yeah,
we're live.
She's coming back here.
Okay.
Yeah, you got to keep on going down.
Yeah, I'm trying to go down, but it doesn't seem to be moving.
Are you out of limit?
So sometimes, you can't visually see 85 degrees south or so.
Right.
The moon has it's called libration. It rocks back and forth, and certain times we can see more of the southern pole.
And one of the characteristics of the moon is that we normally see only one side of the moon. From the Earth, we see one side of the moon. But Kimberly mentioned libration, which is a slight rocking of the moon, which lets us see a little bit more than half of the moon. Now, I'm not sure why, but I can't seem to get it to move.
I've got a good image of the South Pole on mine, or the southern part, not the South Pole. So let me switch over to mine real quick here, and that way we can at least.
Yeah, and with the Viper mission,
let me bring this back down.
We're always going to be when we drive the rover, we'll always have Earth communication, so it is visible from Earth where we're going to be, even though it's kind of like it's on the edge. Looks like it's on the edge.
Yeah, so that's about as good as we'll get on the southern region right now, unless we could figure out why we couldn't.
Let me move it down.
Were you able to, Rick?
Yeah, I'm able to do it fine. It's something.
So maybe it might have been something on the other controller. Okay, why don't you take it back then?
Okay, is this about where you want?
Yeah, you have to take the screen share back.
Oh, okay. Sorry. Let me grab it.
So while he's doing that, a good question came up was, how is it that we are able to date the craters? Well, before the Apollo missions, the only way we could do that is what we call relative dating. Relative dating means we look at and we see, for example, the Tycho crater, it's got a bright rim. We see ejecta rays extending out. That material is all on top of other older craters. So we can say Tycho is younger than, say, the surrounding craters. Copernicus is younger than the Imbrium Basin because we see ejecta from Copernicus laid out across the Imbrium Basin. So
we lost your audio. No. There we go.
Yeah, there you go. Okay. So that's what we call relative dating. But once we had samples brought back from the moon by Apollo and also a Russian spacecraft, but the Apollo missions, they brought back some 800 pounds worth of rocks from the moon from 6 different locations on the moon. And using those rocks, they were able to very positively date those rocks. And from that gives you sort of ground truth. So now you can say, okay, I know what the date or the age is of the terrain around, say, the Apollo 15 landing site, which is right at the rim of the Imbrium Basin. From that, you can then go from being relative dating to actually much more accurate dating. So that is how we do it. We date the Apollo moon samples and the Russian moon samples and use those to establish definite dates for the regions where those samples came from. And then we apply our relative dating to that, and that's where we come up with the dates. It's still a little bit of a hand wave, but it's a lot more accurate than the method that we used before. So we've got a good view now of the south area. Kimberly, if you can maybe guide Rick and tell him about where to point his cursor. You're muted right now.
I think you might be muted, Kim.
Oh, right. Yeah. So the Nobili crater, which I can't quite see with this view, but it's at 85 south, 53 east. So of course you don't have grids on the moon.
Yeah.
So I think I see your cursor now. Well, it's further south. But it's in the murk there. So
it's somewhere down in this area? Okay.
That's right.
All right.
It might be a little bit more to the right, but again, I can't quite make out some features yet. So
can we zoom in a little bit, Rick?
Oh, now they're all pixelated. No. Yeah.
Yeah, don't see much more that way. So, all right, well, down in that region, right?
Yeah, in fact, this is going to be a wonderful opportunity for amateurs, observers of the moon, and also they're very skilled amateur observers with their telescopes with magnification to observe us during our mission, to capture the lighting conditions as viewed from Earth, as a wonderful addition to our science that we're getting, because it's, you know, it's the viewpoint. That's we're looking forward to that collaboration.
Great, great. All right, well, I guess now we got about 10 minutes left. So if we want to take some questions for any of us, and questions about the moon or the Viper mission or marshmallows, whatever questions you might have, now would be a good time to do it.
We do have some questions in the queue. Here's one. Are there any guesses as to the size of the asteroids that created the craters on the moon? And are impact craters still happening?
The answer to the second question is yes. The moon gets hit by asteroids big and small, even today. Most of the rocks and the asteroids that hit the moon are relatively small. These asteroids would be in the category of what we call near-Earth asteroids. The vast majority of near-Earth asteroids are smaller than 30 meters across, which is pretty small, doesn't make a very big crater on the moon. But there are some larger asteroids out there. The biggest near-Earth asteroid today, I believe, is 26 kilometers in size. But a lot of these impacts happened a long time ago, 3.8 billion years ago. And there were quite a few much larger asteroids flying around then. So you can imagine that the Imbrium Basin and the Mare Serenity and Tranquility and so on, and Crisium, all of those craters were formed by pretty good sized asteroids. Also, comets can hit the moon, and comets can be 3 or 4 kilometers across, and they also can produce craters. So it's a combination of both asteroids and comets. But it is still going on today. Another question that often comes up is, does the moon protect the Earth from asteroid impacts? And that is actually not true. The moon is quite small compared to the Earth. It's only a quarter of the diameter of the Earth, and it's very far away. The distance to the moon is about 240,000 miles. That's 30 times the diameter of the Earth. So the moon does not protect the Earth. What protects the Earth is the Earth's atmosphere. The moon doesn't have an atmosphere, so even a small, 4 or 5 meter asteroid is going to make it all the way down to the surface of the moon and produce a crater, whereas on the Earth, an asteroid that size is most likely going to burn up in our atmosphere. So we get hit just as often. In fact, technically, if you do the math, it works out we get hit about 16 times more often than the moon gets hit, but most of those asteroids and impacts are objects that burn up in the atmosphere. And then you have plate tectonics and weather and rain and so on, and that all, and lots of other forces that erode away the craters on the Earth. So we only have a few craters today that we can still see on the Earth. But a crater that happened 3 billion years ago on the moon, there's no weather, there's no plate tectonics, there's nothing to erode it away other than other impacts. So we still see those 3 billion year old impact craters on the moon.
All right, there's a question. Are the craters on the moon equally distributed between the North and South Pole?
No, they are not. One of the things you'll notice is there are a lot more craters in the southern region than they are in the northern region. The northern, not quite half, but a little more than half of the northern part of the moon has a lot more of those big basins that have since filled with lava. So while there are craters within those lava fields, the southern part, what we call the southern highlands, have a lot more craters. The other thing is, if you were to go around to the backside of the moon, you would find that there are a lot more craters on the backside. The backside of the moon, the whole backside looks a lot like the southern highlands that we see on the side that's facing us. So there are many more craters visible on the far side of the moon than on the near side of the moon. And, we sometimes refer to the far side of the moon as the dark side, although it's actually gets just as much sunlight as the side we see. It's just that we never see the back side of it, so we tend to call it the dark side.
All right, we've got a question for anyone on the panel. Do either or any of you have a favorite crater?
Oh, yes, I do. And it's Clavius, but it's not very well positioned right now.
Yeah, Clavius is just below Tycho.
Yeah.
Is that because of 2001?
No. The secret is out now.
Yeah, I guess that.
Let's
Yeah, that's Clavius right there that you
This
were
is
on.
this is Clavius. It's just an awesome crater with
right
all
there.
these. And this is yeah.
Yeah, and it's got the other craters inside of it, so it's pretty interesting. Yeah, Clavius in 2001 is where the moon base was.
Right, the base was there, and then they traveled north to
Tycho.
Tycho.
Oh,
Yeah.
okay. Tycho.
All right, and now Tycho is my favorite crater. So, to each his own, right?
And then Jonas and Cabeus is my favorite crater because I worked on a mission that excavated the bottom of it, found water there.
The lacrosse mission.
Yeah.
I actually worked on that mission also. So
Cabeus is my favorite one because apparently my name is at the bottom of that crater. On the spacecraft. First time I ever get my name on a spacecraft, and it's in the bottom of a crater. So
in perpetual
that is my
darkness.
favorite crater.
And in perpetual darkness, it's one of those permanently shadowed craters. 40 Kelvin. It's like super cold.
At least you made it. Is the moon becoming more distant from the Earth?
Yep. Yes, the moon is slowly moving away from us. It's kind of a complicated explanation of why that's happening. It has to do with the tides on Earth and the fact that the Earth rotates on its axis faster than the moon orbits. But the net effect is that there's a slight offset of the gravitational pull of the Earth on the moon, and that is slowly adding energy to the moon's orbit and slowly taking a little bit of energy away from the Earth's rotation. That added energy to the moon's orbit is very slowly moving the moon farther and farther away from us. It's like I think it's 2 inches a century or something like that.
Wow.
It's not very much, but it is slowly moving away. And as it does so, it takes the rotational energy away from the Earth. So the Earth's rotation is slowly slowing down.
All right, we've got one here from a viewer on YouTube. Says the images I've seen of the dark side show the entire surface to be full of craters, but no lava fields. Is that correct?
And that is
so. Why do you think no lava areas?
That is correct. As we mentioned earlier, the far side of the moon, what he's referring to as the dark side, is the far side of the moon has many more craters than what we see on the near side. The far side does not have as many basins like that you see on the near side, and what few they have are much smaller than most of the ones that you see on the near side. We're not sure why that is. We suspect that when the moon became tidally locked, which is why we only see one side of it, that there are, under those big basins, there are what are called mass cons. So these are areas where there's a denser concentration of mass, which makes the moon slightly lopsided gravitationally. And so we think that's why this side of the moon faces the Earth. But why it is that you got all these big basins in one region, but not on the other side, we're really not sure why that is. All right, any other questions? We're just about out of time here, but maybe we can take one or two more.
What tips might you have for our viewers on observing the moon?
Well, if you have a telescope, the moon is a great object to view with a telescope. If you've got binoculars, you can actually see quite a bit of detail with binoculars. And even if you're just looking with your naked eye, you'll notice the dark and the light regions. And remember, those dark regions are the maria, the seas. Those are the lava flows in those basins. And then the light areas are older terrain, much more battered by impacts. And that's the we call them the lunar highlands.
And I like to observe the moon over time, because it's a calendar. I mean, it's a calendar in many cultures. You know, you watch the phases of the moon, and the moon is up at night 2 weeks of the month, but then it's up during the day 2 weeks out of the month. So you can watch where the moon is. You know, it rises in the east and sets in the west, but it rises it rises earlier each day, and you start seeing these patterns. And I love looking at the moon just to embrace the notion of time. Or like, anyway, I think it's really cool.
Yeah. Now you mentioned the phases. One other recommendation that I have is don't look at the moon very much when it's a full moon, because you really don't get a sense of the texture of the moon. When it's a full moon, the sun is shining straight down on all the features. There are no shadows, so you don't get much sense of the texture of the moon, the depths of the craters and the heights of the mountains. The best time to look is when the terminator is present. So the terminator is the boundary between the lit area and the dark area. So in the left of the image that you're seeing right now, you're looking near the terminator. And as you can see, there are shadows in the craters, and that gives you a much better sense of the depth of the crater and the heights of mountains and so on. So you know, when it's first quarter moon, it's a great time to look, because you can just see all these craters, and you can see the shadows in the crater, a lot of detail. So a little bit of a shadow is better than no shadow at all in terms of appreciating the texture of the moon.
All right, we are just past top of the hour. Any final thoughts?
I always like to point out that, you know, there's a big debate in the community about whether life on this Earth could have been present if we didn't have a moon, because of the unique relationship that we have with the moon, and how the moon had formed from a Mars-like size object hitting the early Earth and spinning off apart. But the fact that we've been together, and the moon was much closer to the Earth in the past, and now we're slowing down and, you know, separating out. But what role did the moon have to bring about life on Earth? And so it's a very precious part of our humanity. And I always look at the moon and think of the Earth, because we were cast together from the same, you know, violent episode in the early solar system.
Well said, well said. Astronomers, any final comments before we leave the air tonight?
Nope. I think that about wraps it up.
I think maybe, Rich, can you go to the wide angle view?
I don't have that anymore.
What happened?
Is that what you?
Just go out and look at it with your eyes.
Yeah,
If you
really.
really,
Well,
yeah,
look at
exactly.
yours.
If you want a wide angle view, go
Yeah.
over to the window, Rick. Over to the window.
Now, was that a good setup or what?
I know.
Yeah.
He's sitting here watching me disconnect my camera and then asks me to go to the wide angle view.
So that's what you were doing while you were doing your Darth Vader act.
That's right.
Well,
right.
let me say thank you on behalf of all of our guests who are watching. I know that we all learned something. Thank you to our special guests from NASA, Jonas and
Yes.
Kimberly. It's been wonderful to have you. I hope it won't be the last time. Eat your marshmallows, get the name brand ones.
That's right.
That's right.
I'm never getting those store-bought marshmallows
Nope.
again.
Done. Name brand only.
Thanks to the folks at NASA behind the scenes that you can't see tonight. Thank you, David, behind the scene. Rick, we didn't shout you out. Thank you for joining us, working with us behind the scenes. And don't forget, opening weekend, November 12th to 14th. I will be looking for you here.
And if you're on Facebook, click that donate button and help us out. We certainly will appreciate it.
I would like to mention that next Saturday night, we will not be having a virtual telescope.
Yes.
It is a fundraising event for the Chabot Space and Science Center, the annual gala, and we're going to be tied up with other related activities that night, but we will be back the following week.
Yep. Yeah, you don't want to see us in tuxedos anyway,
Yeah.
so.
Yeah.
Well, I also might mention that's a good time for reruns of the of the astronomers at Chabot.
Yeah,
So
that's right.
if you need another telescope fix or celestial fix, look at one of those reruns on YouTube or Facebook.
Yeah, there you go. All right. Well,
well, thanks again for joining us, and we are signing off. Good night,
all
everyone.
right. Good night,
Good night,
everybody.
everybody.
Good night,
All right.
everybody.